Hello everyone, welcome to this video. I'm going to show you how to create regression lines and regression curves. And I want to briefly just go over some things about why we use these. And I've highlighted in the notes just some quick things. So you probably know by now that when two variables are related and you make observations and you plot points that you observe, you can create this thing called a scatter plot. And if there's a trend in the scatter plot, it is often helpful to find a line of best fit or a curve of best fit. And the calculator does this for us very easily. And before we get into doing that, I wanted to quickly point out some of the things that I highlighted here in the notes. When we create a line of best fit, some things will come up that are important and worth noting. In particular, number one, this correlation coefficient is a number that indicates the strength of that association. So first of all, if that sign is positive, and we're talking about a linear line of best fit or a linear scatter plot, the sign of that correlation coefficient is going to give the direction. So if your correlation coefficient is positive, it means that the line of best fit has a positive slope. And if the correlation coefficient is negative, it's going to indicate a negative slope in the data and in the line of best fit. Next, you'll see that the correlation is always between -1 and 1. And the closer we get to those extremes means that you have a very strong association. Anything in the middle, closer to 0, means the data is like a cloud. There's no trend among the data. In that third bullet there, I have a correlation of 1 or -1 rarely happens. What that would mean is we don't really have a scatter plot, but we just have a line where all the dots are exactly on the line, and that's not going to happen probably at all. And on the fifth bullet, I noted that correlation has no units. It's not measuring a distance. It's not a unit of length or anything like that. And then finally, I highlighted the question, how strong is strong? Well, like all things in statistics, it's subjective. It's based on what you believe. So all we can really say is the higher the correlation coefficient, the better the fit. The way you describe something might be different than the way somebody else describes it. So having said all that, I wanted to show you how to use the calculator to create regression equations. We're going to do just linear ones today. And once you get the hang of doing this, the next time we're in class, we'll talk about ones that are exponential, ones that are quadratic, depending on the shape of the scatter plot. So I'm just going to go through these directions. I may fumble once or twice because going back and forth, I may miss a keystroke here or there. I may edit them out. We'll see what happens. So what we're going to do first, I'm just going to open up a new document. I like to always do that. You don't have to. And it's going to ask you, what do you want to do? What do you want to add? Well, I would like to add a list and spreadsheet. So we're going to go there. I'm now going to title the columns. If you wanted to, I don't know what these data are representing in the table, but if it was like, if one represented units of time, you could title that time. Or whatever it represents, you can feel free to title it. I'm just going to label these XC and YC for X column and Y column. Okay, so we have that columns highlighted, and we're going to enter the data into the graph. I'm going to go slow so I don't have to double check this. I probably will anyway. 10, 12, 14, 16, 18. And we're going to go from the bottom up, or top down, 10.4. 8.9, 7.9, 6.3, 5.1, 4.7, 2.6, 1.3, 0.1. I'm pretty sure I entered that incorrectly. I'm giving it a double check. Pause the video if you're a little slower getting the data in, and just pick it up when you're ready to go. All right, so we've got the data in. That's just like step A. Oh, we didn't add the graph yet. So let's add a graphs page. Okay, so on the document menu, we're going to insert a graph. Okay, so let's see, we've got step A is done. We entered the data in, add a graph. Okay, so now what we want to do is we want to see the scatter plot that we've created in our spreadsheet. So we're going to go to Menu, and a lot gets done here in option 3, Graph Entry or Edit. What we want to do is, despite what the notes say, we actually want to do Graph Entry Edit, and the sub menu is going to be 6, not 5. We want to enter a scatter plot. And it's going to ask you, what column do you want to use for the x values? Well, we called our x column XC. And what do you want to call the y column? Well, we want to use YC to feed our y values. I hit enter, and you can't see the scatter plot because it's above. It's actually living up here somewhere, but I'll show you how to view that. Okay, so now step D says change the window so you can see all the data. Well, how do we change the window? There's a great setting on here on the Nspire. If you go to Menu and Window Zoom, you can find an option in the sub menu called number 9, Zoom Data, and there it is. I'm going to get rid of this label here. Okay, so now we can see the data in the scatter plot. Well, now we want to go back to the spreadsheet because we want to make our calculation for the line of best fit. So let's go to 1-1, and I want you to find an available cell. C1 for me is the first available cell. And now how do we actually make the equation of the regression line? So I'm going to go to Menu. I'm going to go to Statistics, which is 4. The sub menu of 1, I'm just going to hover there. And then the third option on that sub menu is linear regression of the form mx plus b. And it wants to know some stuff from you. What am I using for the regression for my x values? Again, that's xc. What am I using for the y values? That's yc. And very nicely, it's offering to store the equation, the regression equation, in F1. So if we ever want to use that, we can call it by name. It's going to store it in F1. Okay, so we're ready to go. I'm going to hit OK. And you can see in columns D and E, it puts the output of our work. It's saying, okay, I made you a regression equation of the form mx plus b, where m is negative 0.635. Let me go back to that graph for a second. Does it make sense? Yes, the slope is negative. The slope of the regression line is negative 0.635. And the y-intercept is 11.6. Does that kind of make sense? I think so. That value up there is 11.43, so that's going to be the y-intercept, and it's probably going to go something like this. But let's find out. I'm going to go back to my tab. And r squared is not the regression or the correlation coefficient, it's r. So scroll down one more to r, negative 0.996. To me, that's very strong. It's almost 1. So I'm expecting when we make the equation, or when we graph the equation, it's going to really fit a lot of those points very neatly and very tightly. Okay, so let's see where we are in the directions. We did F, we did G. Take a look at the results and find M and B. Write the equation down. We did that in the notes today. Now we want to actually plot the regression line. So I'm on step J. So I go back to the graphs page. That's this tab here. Okay, and if you enter Menu, and then I want to do an entry of a function. So it's graph entry 3 submenu 1. Now why does it go to F2? Because it already stored our regression equation in F1. It didn't plot it. It didn't think we wanted it plotted, which is the default. So what I'm going to do is I'm just going to hit enter, and it's going to plot it. And as we thought, or as I thought anyway, I'm sure you may have as well, you see that's a very good fit for the line. It's going through most of the points, with maybe one point being like away from the line. So negative 0.996 is a very strong correlation equation, a correlation coefficient. Okay, so that is really the idea. What we can do is now we can go back and I'm going to do example 2 with you, and then I'll stop the video. So if you understand by now, feel free to X out, but I'm going to do these last two. So I always like to open a new document. So I'm going to open a new. I'm not going to save the old. I'm going to add a list and spreadsheet. I'm going to go XC. I'm going to go YC, and I'm going to enter my data. 0, 1, 2, 3, 4, 5. Now I'm just going to make some observations as I enter the data. It looks like as I'm entering the data, 24.5, 27.0, as the x values go up, the y values go up. So I'm going to expect a positive correlation or a positive slope. I don't have any idea what the scatter plot looks like, but we can certainly find out. Okay, so got the data right there. Let's go menu, insert, menu, I did the wrong thing, doc, insert graph. Okay, and then from the graph menu, graph entry, let's insert our scatter plot. Again, XC, YC. If these directions are fast, I hope you're pausing and trying to do the keystrokes on your own. Again, you can't see the data, right? It's way up there because the data are like 0, 24.5. So I want to go to menu, zoom, and zoom data. There we go. There's the positive correlation. It looks to me like these are pretty tightly connected. Okay, so I'm going to go back to my spreadsheet. I'm going to find cell C1, and it's menu, statistics, stat calculations, linear regression, XC, YC. Store the equation in F1, enter. These are, if I ever ask you on a quiz or a test to write this stuff down, here's the equation of the regression line. 2.163x plus 24.676. All right, so we have the equation of our regression line. However, it's already stored in F1, so if you're doing work on the calculator, we'll be okay. Let's go back to the graph, and to get the regression line, it's menu, graph entry of a function. Remember, F1 is already in memory. It's up there, hit enter, and there's your line of best fit. 2.16 plus 24.7. Right. Let's see 1 second here. Yeah, okay. Let's see something here. Yeah, the only thing, what looks confusing is that negative 0.5 is actually an x value, not a y value. I don't know what the gradations here are on the x-axis. We did zoom fit, so it's like zoomed in on a particular area. So I can't exactly tell you. But actually, I can tell you because the equation of our regression line was what? Plus, let me go back here, tab. That y value down here is about 24.6. Okay, I'm going to do one more. I'm going to do example 2b, data set 2. All right, hopefully if you've done this or you're doing this for the third time, it's becoming old hat for you. Add list and spreadsheet. I'm going to go XC. I'm going to go YC. I'm going to go 30, 35, 40, 45, 50, 55, and then 787, 902, 1024, 1136, 1247, 1364. Another positive correlation. I have no idea what the scatter plot looks like, but let's find out. Okay, so we've got our spreadsheet entered. Let's go here. We want to add a graphs page. So we're going to go doc, insert a graph, and then it's menu, graph entry, scatter plot. XC, YC, enter. We can't see the data. Menu, zoom, zoom data. Now we can see it. And then we want to enter in our line of best fit. So 1 second here. I just want to check something out off the screen. Did we do our regression yet? I don't think we did. That's what I was looking for. We didn't do the regression yet. So back to C1. Okay, so once we're in C1, it's menu, statistics, calculations, linear regression. You know, sometimes it's going to be a quadratic regression. Sometimes it'll be an exponential regression. You'll have to look at the shape of the data in the scatter plot and decide what is best. And a lot of times these are subject to your opinion, but you have to make sure that when you come up with the regression equation, that future values are tightly attached to the line. We'll get into that another day. All right, so XC, YC, F1, okay. These are the ingredients to our regression equation, 23.04x plus 97.47 or 467. And yeah, it's a very, very good correlation, 9999, very strong. Okay, so once we have our regression, we're going to go back to the graph page. And do you remember what to do? Menu, graph entry or edit. We want to enter a function which is already stored. Arrow up, enter, and look how good that line of best fit is. Strongly correlated to the data. Okay, so I hope this makes you feel comfortable using the calculator. Next time we get together, we're going to finish the packet. We're going to talk about quadratic modeling or quadratic regressions, exponential regressions. I'll give you time in class to start working on some of the problems, and I'll give you the rest for homework. And we'll talk about the Unit 1 assessment that will be coming up.